Good morning.
是这儿。你的那个数学本拿出来以后，就固定一个每次上课用的那个本。上一次不是有？
你不要争了，等一下我这儿贴一下，专业别忘了。
All right. Good morning, everyone. I think this is the first class done for 5A. I guess I will start off with a little bit of myself. My name's Daniel. You guys can call me Daniel or Mr. Lee or some form of that. I am a recent graduate student, or I recently graduated from the University of Texas at Austin. And yeah, that's kind of my background. So this class will be kind of a backwards class because the material that we will cover, or like the kind of learning material, is more of a comic. And so I thought that it might be easier for homework for y'all to just read through comics. Maybe do some of the questions if you guys feel like it. And then, but we'll go through more of the hard questions and kind of also a review usually at the beginning of class. And then so classes will be structured in a way where during class, I'll start off, maybe give a slight review of the material that was covered. We'll do some of the easier questions, and then we'll work on some of the harder questions that was not assigned for homework. And hopefully y'all will be able to learn from those examples. And then the homework assignments will be generally just some of the comic book chapters that you can read, and then maybe some of the problems if you guys feel like doing it. So that being said, can everyone see my screen?
Yeah.
Great. Also, I can't really read Chinese too well, so I can recognize some of the characters, but not all. So if you guys could give me an English name, that would be very helpful. This is kind of our overall overview for this year. There are 3 big chapters. So the first one is 3D solids, then integers, then expressions and equations. I believe there are 12 chapters in total, so 4 books. This should be the first one. And I think the way we're going to pace the classes, we should try and finish a chapter every 2 to 3 class lessons. Since we haven't really covered any material, I guess we'll cover some of the comic book stuff first, and then work on some of the problems related. But in the future, I will be assigning like these chapters for you to read. And then that way, when we start, I'll give a short overview and we'll just go straight into working on the problem sets. That being said, let's get started. So I think we'll probably be able to cover the first 2 comic chapters or close to finishing the first 2.
Some of these chapters I already learned.
Is that true for everyone? Is there somewhere that chapter you would like me to start off, or is there some that have learned some of these and some that haven't? Okay, I'll take that as some people haven't learned this, so I apologize if this beginning part is a bit slow, but we will try and cover most of the material or all of the material. So yeah, can I get some, does anyone want to volunteer to help me read through this?
I can.
Okay, so Eric, Brendan, pick, I guess, can one of y'all be blue and one of y'all be orange?
I mean, I can be blue.
Okay, and then Eric, do you want to be orange?
Nope.
All right.
So do I start reading now?
Yeah, go for it.
Okay. You know, we really don't get enough culture in our lives.
Yeah, this is nice.
Read the sign. End heads, end tickets.
1 ticket, please.
Oh man.
I hear they've opened a fantastic new 3D exhibit.
$3D?
3D stands for 3-dimensional.
Huh?
A dimension is a measurement in one direction.
Example?
This line segment has 1 dimension. We can only measure its length. Other objects have 2 dimensions. Take this rectangle for an example. It has 2 dimensions, height and width.
I get it. So all of the shapes in this display are 2-dimensional.
You got it.
Okay, so I guess I'll quickly jump in here. Does that make sense for everyone? 1D is just line segments, rays, that type of level.
Yes.
2D is when you have 2
Yeah.
lines that kind of form into any of your 2-dimensional shapes. Brendan?
So flat shapes are all 2-dimensionals.
Right. A flat 2D shape is sometimes called a plane shape. Plane shapes have height and width, but no thickness.
Yeah, so plane, go for it.
I see. So a 3D object has 3 dimensions.
Yup, let's check out this 3D exhibit.
Cool.
All these pieces are 3-dimensional solids.
They take up space in 3 dimensions.
Yep. And so now we have, instead of just the plane, which is the width and height, we also have thickness. And yeah, shadows can be an example of 2D because they only have, they're projected onto a flat surface, so they only have width and height, just like these flat surfaces. Brendan?
And it's not just the art, all of the objects around us are 3-dimensional.
I wonder what's in here.
It's just a, no, I mean, it's just a tiny speck. I don't get art.
I think that's the point.
Why is it called a 0D exhibit?
So 0 dimensions are supposedly just like a infinitesimally small point. So lines are the distance between 2 points. So that's your one dimension. You can think of it as just one length. So like here. And so 0 dimension, I think, is really just a singular point, although dimensions and stuff does get a lot more complicated as you get older. So I don't have exact definitions since I wasn't in that field of study. But to give a simpler example, points, 0D, lines, 1D, your basic shapes, triangles, squares, circles, stuff like that are like flat, 2D, and then 3D is like cube, prisms, and stuff like that. So this is kind of the first chapter, just the introduction on 3D shapes. We have some of the practices, I believe, that go into, let me see. They have some guide here. 12 to 25 is 7 to 13. Oh. Well, I guess we should probably, okay, so this is 2D review, sorry. And then we have 18 to 23. So I'm assuming y'all are familiar with two-dimensional concepts like perimeter, area, and stuff. So can I get some volunteers to help me go through these questions? Johnny, do you want to go take me through the first two?
I'll try, since I haven't.
Okay, I guess kind of for those who don't know, perimeter is just adding up all the side lengths. It is what boxes in a shape, and then area is the shaded in here, is what area stands for. So how would we, I guess for the first one, perimeter, how will we do get this answer?
Just add all of it up.
Okay. Yeah. So we have. Oh, not really what I wanted to do. Sorry about that. So we have 17 plus 13 plus 10, because 2 5s, right? What is this, Johnny?
40.
Yep. So we have 40, and then remember your units, so inches. How would we do area?
The area's formula is length times width.
Right. So for this shape, there's no real exact length and width. So it's a bit harder to do than just a normal shape. How would you guys go through doing it? I can do like some of the number crunching if you want.
I think I would do it 17 times 5.
I would do 5 times 5, then 12 times 13 divided by 2.
Okay. So
12 times 5 divided by 2.
Yeah. So I guess the simple idea, right, is break it up into two shapes. You can either do this way where we have two shapes, or you can do the long way where we have this bigger rectangle and then subtract what's missing. So this is 25. Oh, let's stop my drawing. This is 25, right? And so this is 5 here. 17 minus 5 is 12. And now, so divide by 2, 6, 30, right? So that gives us a total area of 55. And then area is two-dimensional. So kind of what we're looking at is counting up the length of the lines. So if we unrolled the lines out for perimeter, area is a 2D plane. So our units also have to be like two-dimensional. So inches squared. All right. Do you want to continue, Johnny, or for the second problem? Does anyone else want to try and do second problem?
I can.
All right.
So for the perimeter, instead of adding 3, you can just do 15 plus 4 is 19, so it's 19 plus 13, which is 32. So the perimeter is 32.
right? And then area. How would you go about doing this?
For the area, it tells you the height is 12.
Right? So we have like some
So it would basically be 4 times 12, if I guess correctly.
so 4 times 12 divided by 2, that's the I guess area of triangle is 1/2 base times height. But that's for this whole triangle, right?
Yeah.
So how would we get only this sliver right here, the shaded area?
So we could do 12 times 4 divided by 2.
12 times what?
I said 12 times 4 divided by 2.
So that would be something like this, right? Where we would have a triangle that's 12 right here, and then base 4, and then the area would be here, right? So I kind of want you to see that the approach for this type of stuff, and I think I guess, is it Bei Chen? You want to
Yeah.
go for it? Explain
13
what.
times 4 divided by 2.
No, okay. So the kind of concept I want to elaborate is we have two shapes here. There's this big triangle, right? And then there's this smaller triangle right here, right? That's like empty. So the idea to get this area is you take the larger triangle that's encompassing this, subtract by this smaller triangle, which is a right angle triangle that you know, to get this the area right here. So in that sense, the first thing we should do is we need to try and figure out.
Someone said in the chat 13 times 4.
13 times 4.
Yeah, someone said in chat.
Oh yeah. So that's not exactly right, because this base times height kind of idea is really only applicable to right triangles. And so the idea behind that is for a square or a rectangle, you know that it's like length, or I guess here is length and this is width, but yeah, right? Length times width. So these guys, these rectangles all have 90-degree sides, and kind of the idea of the triangle is we have this triangle here. So length here would be our base, and then this width here would be our height, essentially. And so to get this, only this triangle part, it's just height times the base divided by 2, because we only take 1/2 of it.
Can we like first find out like the entire triangle's area, and then subtract it by the other triangle's area?
Yeah, so but before that, we need to find this length, right? So if I want to find this big triangle's area, I need base times height, 1/2 base times height. But we don't have the full base, right? We don't know the length of that. So does someone have an idea on how to go about solving for this? I guess Eric, do you want to chime in?
I'm not sure about this one.
Okay. Have you guys done I guess solving for like Pythagorean theorem and stuff?
I think I got an idea.
Okay, shoot.
I think it's 13 times 4.
So
Already tried 13 times 4 a bunch of times.
yeah, I mean we can double check to make sure, but I kind of I'll go through this way. So if you have two sides of a triangle, right? Say this is 3 and this is 4. Do you guys know how to find this this
Yes,
side?
I know how to. It's like a 4 times 3 divided by 2.
That's area. But I'm talking about this this question mark, the side of this thing, like what this length is. Okay, so to find out missing lengths, there's this, I guess, equation where you take the squares of your, I guess, bases, and then you square root that to get the missing side. If you have the smaller bases, so like 3, 4, so 3 squared is 9, 4 squared is 16, and then taking the square root of, well, I guess of this. Internally, this is 25. So square root of 25 is equal to 5. So then this side would be 5. And these are known as like Pythagorean triples, if you guys have heard of that. So here we have kind of a variant of that. We have 15, 12, and 15 is just 5 times 3. 12 is 5 times 4. Or sorry, 3 times 4. And then, so I should probably write this as 3 times 5. And then, so we expect if this is, these Pythagorean triples scale up like ratio-wise. So if I multiply all these by 3, right, I have one side with 12, one side with 15. So the other side must be the last one, which is 3 times 3. And so here we see that the original triple pair is preserved right here. So this long side length right down on the bottom is actually 9 inches. Does that make any sense to y'all? I guess I don't want to add too
It
many
makes zero
concepts.
sense. It makes 0 sense.
It
Okay,
makes
okay.
negative 0 sense to me.
Okay.
Uh,
I guess, do y'all understand our base? The main goal right now is we're trying to figure out this length, right?
It makes sense to me.
Would you like to? I guess for those who don't, it doesn't make sense. Can I ask where does it not make sense, or what have y'all? Where did y'all get lost?
everywhere. I got lost in the first word you say.
Okay, so does this make sense though that we need to find the length of this line because we don't have the length of this line?
Yeah, that makes sense to me.
Okay, so if I have a triangle, right, and this is kind of just like, I guess, a formula that you'll learn later on, but essentially we have this formula called a squared plus b squared equals c squared, and it's in regards to how, if you notice, we plug 3 in for a. By the way, have you guys worked with squares and square roots before?
Nope.
I know a little square
The
root.
squares.
Okay.
I work with squares, but I only know a little square root.
Okay.
Same.
So let me teach that concept. Now it makes me feel like there's probably some easier way to go through this, but let me think. Give me a second to see. Yeah, don't really see the easier way, but squares is essentially you have 2 things multiplied to each other. So like here, I guess this is a easy reason why they're called squares is if I have a line that's 5, right? Then the square of 5 is the area right here because I'm multiplying 5 with 5, which is also why they're known as squares. So this area is the square of 5 or 25, right? So when I write the notation of like 3 squared plus 4 squared, what I really mean to say is 3 times 3 plus 4 times 4. And then this should equal some other thing times some other thing. So that's the concepts of squares and square roots. So square rooting this is just taking one of the terms. So if I have 9 and I do the square root of it like that, it's saying what do I need to multiply with itself to get me 9? And in this case, 3 times 3, 3 multiplied by itself gets you 9. So 9's square root value is 3. That is kind of a short introduction to exponents and square roots. Did that make sense, or?
Yes.
Okay.
Exponents, because during the summer I did learn it because I'm in 6th grade this year.
Okay, cool. I don't quite remember. Oh, so I would like to say math doesn't need specific grades. There are just like certain things that you should you end up learning. So it's more like I like to put learning not in terms of grades, but in terms of concepts that you end up having to go through. It's just that school system takes, hey, I have some of these concepts. I will call this one grade. So you should learn these concepts by the end of this year or something like that. But realistically, it doesn't actually depend on how old you are or what school year you're in. In that sense, this idea of we have something, some squared plus some squared equals another squared. So in this case, a squared plus b squared equals c squared is the most common form of this formula. So to kind of put an example here, if I have 3 squared plus 4 squared, what is this equal to? Can someone tell me the answer? I think Sophie, you
25.
just muted. Yeah. So 25. So now, if I want to know, if I want to get it into this form, basically I'm looking for C, where C times C equals 25. So do we know of a number that can do this for us? Anything times
5
itself
times
gets to
5
25?
equals 25.
Right. Okay. So the initial easy concept to know is that these things kind of are ratios of each other as well. So like if I multiply all this by 2, so say I have now 6 squared times 8 squared, or sorry, plus 8 squared, this will get me 10 squared, where this is just the 3 times 2, and then 4 times 2, and then 5 times 2. But you can do it also just like normally as well. So if I have this 15 squared, that was a mistake. So I have this side and this side, and based on kind of what we've been showing, let me clear some space actually over here. We don't need this anymore. So this is kind of the example that we gave, where this is 3, this is 4, and this is 5. So the hypotenuse is always the longer length, and in this case, 15 is our hypotenuse. So we already have c squared right here. So we have this form of the equation now. We have a squared, which is 12 squared, plus b squared equals 15 squared. And so now the idea is what we're trying to find b squared, right? So it is b squared equals 15 squared minus 12 squared. Does that make sense to everyone?
Yeah.
And then this is just 225 minus 144. And this would equal to 81. So we get that our b squared, let me just clear all the drawings. So this is what we're trying, that's terrible, my bad. This is what we're trying to find out. We got that 15 squared minus 12 squared equals 81, which is equal to b squared. And b is this length that we're trying to figure out. So does anyone know of something multiplied with itself that gives us 81?
Nine.
Yeah. So in that sense, b is 9 right here. So we end up getting that this small length right here is actually, so if this is 9, then this must be 5, right? Does this make sense to everyone? So I don't know if we're supposed to teach you like about all the squares and square roots, or if I was supposed to give this to you on my own. But that's kind of how we get the length. And now once we have the length, things are a lot more straightforward. So we have this big triangle, right? That looks like this. So we first want to compute this guy's the big triangle's area. So can I get a volunteer to do that? To tell me kind of like the formula at least. What's your name? I can't read the Chinese, sorry.
Is it the exponent one?
So it's just your standard triangle theorem or calculating the area. So 1/2 of base, which is 9, height, which is 12, right? We see that 1/2 and 12, so that's 6. So 9 times 6, 54. So this becomes 6, and then 9 times 6 is 54. So this is the big triangle's area. Now we need to figure out the small triangle's area. So I'm going to just have 54 up here. And then we had got that this was 5. So given that we did the big triangle, does someone want to give me the answer to the small triangle? Go for it.
Okay, so it's the area is 30.
Of this one?
Yeah.
Yeah, because we got 6 times 5. So I guess the big concept of this is that we have this bigger triangle and then we have this empty region. So to get the shaded region, it's the big triangle shape minus the smaller triangle, which will get us to this kind of shape. Does everyone kind of see that, or like kind of that thought process? And that's why also when in the first question, I was like, you can either split this up into 2 shapes, or alternatively, you can also split it up into this rectangle subtracted by this empty triangle right here, where this triangle would be 5 and 12. So then that would also have given us the same answer for the first problem. So this leads us finally to our area is 24 inches squared. Does that kind of make sense to everyone? I don't want to kind of go for it if people don't understand this. Or at least kind of how, assuming you had the length, because I know maybe we're not, maybe you guys haven't learned about like Pythagorean theorem or squares and exponents yet, squares and square roots. So assuming they gave you this 9, does everyone see why we were allowed to, how we combine shapes and subtract shapes to get the area? Okay. Does someone want to do question 3 for me? Okay, go for it.
What is the perimeter of a regular
Pentagon? Yep.
Pentagon with sides of 35 centimeters. Okay, so a pentagon has 5 sides.
Mhm.
So we can do 35 times 5. It's much easier to do the multiplication.
Right.
And you have to have similar sides.
Yep. So for this to work, obviously you need to make note of the fact that they all have side length 35, which is right. So in that sense, we have 5 sides, so we are allowed to do 35 times 5. Now note that this is like 5 sides, but so it's kind of unitless, which is why because this has no units, when we do the when we still solve for perimeter, it is still going to be end up coming to centimeters over here. And so this is just 140 plus 35, or 175. Now this one, we have a right triangle whose like lengths are 7 and 13. So we're tasked with finding this area. So does someone want to solve it for me? Or at least walk me through what you would do.
So what I would do is 7 times 13, and then just divide that by 2.
Right. And so we end up with this. So let me just quickly get that out there. So 91 over 2 millimeters. Do you know the units for this?
Millimeters,
And then?
and then squared.
Yep. So the idea is we are multiplying these. And so this is actually 7 millimeters. And this is also 13 millimeters. So you can separate your numerical calculations like this. But since each of these are millimeters, then it's like times millimeter and then times another millimeter. So that's why we have, or that's how you would kind of multiply with the units. All right. A square with side length 4 meters is cut out by a 5 by 6 rectangle. What is the area of the remaining shape?
A square's sides are equal.
Yep, that's good to note. So our square, so I guess with this square with side length 4, what's the area of the square?
16.
So I guess note we're solving for area. Yeah, so the square equals 16. And then it's cut out of this rectangle. And so what's the area of the rectangle?
30.
Right. And so since we're cutting it out, it's subtraction. So now we're left with 14 meters squared.
14.
Okay, so 6 equilateral triangles, each with perimeter 16 feet, are attached to create a hexagon. So what is the perimeter of the hexagon? So can someone explain to me the question with this drawing over here? Go for it. By the way, what's your name? It's like Wang something.
Wang Guanghong.
Wang Guanhu. Okay. Do you prefer to go by an English name or do you want me to call by your Chinese name?
Sure, you can call me the English name.
What is it, by the way?
My classmates call me Juji.
Juji?
Yeah.
Okay. I will remember that. Sure, go for it. Can you explain to me using this kind of the question?
Okay, so each triangle has 16 feet.
Yeah, so each of my triangle, the
We have
perimeter
to
is
find
16
out the
feet.
length of each side. Okay, so we just need to do 16 times 6. And then it equals
Oops. Do people agree with this, by the way?
96. And then it equals 96, and we just have the area. So we don't want the area. We want the perimeter. So we have to divide by 3. So you have to do the 16 divided by 3. It's the area.
Oh, oops.
But now we need to find the perimeter. So we can just do 16 divided by 3.
Okay. 16 over 3.
To find one side length.
Uh-huh.
Okay, so 10 divided by 3 equal, we can only do the maximum number is 3, and then we just have 1 left.
I mean, we can just keep it in this form for now. To find the hexagon side, does everyone see that? 16 is the whole perimeter. We have 3 sides. So since they are equilateral triangle, an equilateral triangle by definition is that all sides are equal. So each side is then 16 over 3. But then the question is asking, we have this hexagon. And kind of if you notice, we have hexagon is 6 sides, and each one of these is the 16/3. So the reason why I don't want to directly compute 16/3 is because we end up getting rid of this like pesky divide by 3 anyways, because we have 6 sides for hexagon. So we multiply this by 6 to get the perimeter. So then we can cancel this, and this is 16 times 2. So sometimes it's easier to simplify later on because there will be new variables that will cancel out things that don't look so well. So does it make sense how we got to 32 feet?
Yes, I think okay, it makes sense.
All right. Cool. That took a bit longer than I expected, but hopefully we can at least go through the next chapter's comic. Can I get another couple of students who pages 18 through 23? Yep, that's what we're on next. To help me read through this.
I can be the green.
Okay. Does anyone else want to help?
Can I be the yellow?
Okay, sure. Who was that, by the way?
Eric?
Eric? Okay. Eric is yellow. Brendan's...
Can I be blue?
Okay, sure. Brendan's green, Juji's blue. All right, and I will be, if we have any other, I'll be purple, I guess. So I think, Eric, do you want to start us off, right?
Okay. Line up, pollywogs. Today's physical training will help you improve your balance, stamina, and coordination.
Stamina and coordination.
In front of you is
Wait, question. Where's the green? I thought.
Green is talking down here.
Okay.
Yeah, I had to double check as well that there was green talking, but yeah. Okay, go for it.
In
Sorry.
front of you is an obstacle course made of prisms, pyramids, and various other
Geometric
shapes. Solids.
What is that?
Some of you have not learned to identify the major groups of three-dimensional shapes. Who can tell me which one of these obstacles is a rectangular prism?
I guess real quick, does anyone know from just looking at this?
I know.
Okay.
It's the first one.
Okay, this is a prism. I think I see another one. Does anyone else see the second one?
Yeah, it's the third one.
This one?
Yeah.
So this is a triangular, yeah, triangular prism. Yeah.
I know. Oh, the second one, and then like there's one in there in the
Right.
group.
Yeah, so there's this red one here too. Cool. Brendan, I think this is you.
Sir, the big blue one, sir.
Very good, Tinkerbell. What makes that solid a rectangular prism?
Sir, a prism is a solid with two congruent faces down a parallel. These congruent faces are called the bases of the prism. We name a prism by the shape of its bases. The bases of this prism are rectangles, so it is a rectangular prism, sir.
So the bases here, or at least for a rectangular prism, it's just like orientation is what matters. Not necessarily that it has to be this top base and this bottom base, but I believe that's the two bases or two congruent faces that are parallel that they're talking about in this comic strip. So if you notice up top, the reason why it doesn't matter as much for rectangles is because even if your two bases are rectangular for the rectangular prism, your other faces are also parallel and also rectangular. So it's just a matter of which way you end up turning or orienting the shape. But for other shapes like this triangular prism, it actually does matter because these sides right here that go up and down are rectangles, not triangles. Whereas the bases, the one at the top and the one at the bottom right here, those are your triangles. So that's kind of to give a example of what they mean.
Excellent. You will begin my obstacle course by climbing up one face of the rectangular prism. After climbing down the opposite face, you will continue to the set of 6 smaller prisms. Hop from the triangular prism to the rectangular prism to the pentagonal prism to the hexagonal prism to the
Heptagonal.
prism, and finally onto the octagonal prism.
And then real quick, this is 7 sides, known as the heptagon. So I see. Oh, that's not what I wanted to do. This octagonal prism has an octagon on top and the same octagon on the bottom. The octagons are the bases, and the bases are connected by rectangles. So the rectangles here are this little area. That was pretty bad, but if that makes sense. And then the octagons are the bases right here, up and down. All right.
The next obstacle will test your balance. What do we call this polyhedron? Hammerhead.
So geometric solid whose faces are all flat is called a polyhedron. So a lot of our rectangular prisms, or not just our rectangular ones, but the prisms are also polyhedrons.
Sir, it's a triangular prism, sir.
Excellent. Regardless of which face is on the bottom, a triangular prism is still a triangular prism, and its faces are still triangles.
Yep. So we have our rectangle here, and then our triangles again.
Maintain your balance while walking across the edge of this triangular prism. Next, you must cross this moat using these 5 pyramids. Okay,
so real quick, so edges are where the faces meet. So you can think of them as like the perimeter of your shapes. So here we have this edge right here, but also these are edges up top, and same thing here. And then I don't know if it'll mention later. Oh, it does. Okay, so I'll the point where they meet is called a vertex, and you'll see that because they mention it down below. Yeah.
The base of a pyramid can be any polygon. The remaining faces of the pyramid are triangles that meet at a single vertex. The vertex where all the triangular faces meet is called the apex of the pyramid.
Yep. And so vertices is the plural form of vertex, but a vertex is any point where all the edges meet. In the above example, the vertices here are going to be this point, these 3 points, and then these 3 points over here. And then there's one invisible one over here, but you get the point.
Hop from the square pyramid to the pentagonal pyramid to the hexagonal pyramid to the heptagonal pyramid to the octagonal pyramid and to the opposite side of the moat.
So the only real difference kind of between prisms and pyramids is they only have one base instead of 2 congruent faces. But the bases, just like with the prisms, are going to dictate what, I guess, prefix you say before pyramid. And unlike the prisms, where all the prisms, right, they were like rectangles right here. The pyramids are all triangles on the sides. So those are the two notable differences between them. All right.
You must complete the remaining obstacles as a team. After you have all crossed the moat, you must place the sphere atop the cylinder. And finally, you must work as a team to place a flag on the apex of this cone.
Okay, yeah. So we have three new shapes: the sphere, cylinder, and cone. This is because circles are very cool kids. They're very special people. They don't actually have edges, unlike our normal or our other shapes like triangles, right? We have edges. Circles don't have edges. So if you think about it, a cylinder is really just a circular base and a circular top. And then this is just like one long rectangle that wraps around to the end. And so really what a cylinder is kind of a cylindrical prism, but it's not a prism because it doesn't have those rectangular edges, but that's okay. But you can think of it kind of as such. And then the cone here is gonna kind of be our cylindrical pyramid. So we have a circular base and then it all goes up to one point. Does anyone remember what this point is called?
An apex?
Yep. So in that sense, they are very, very similar. It's just because they don't have any edges on the base shape, we have these unique names for these circles because they don't really fully satisfy our definitions of prisms and pyramids. So a sphere here is the math word for ball. Cylinder is like a prism, only its bases are circles, and cone is like a pyramid, only its base is a circle.
You got it, Grade 8. Now line up on the starting line. You'll be timed. Are there any questions? Go!
So we have them hop around and have some fun. All right, so that kind of concludes our second chapter. And then you can have some fun reading through the different prisms here that they use to make different, looks like they're like transportation vehicles, like looks like a spaceship, nice little truck. These look like houses, kind of. Battery, you have your beach ball, a garden gnome, and then you have some other more stranger shapes, like the isohedron, which is just 20 equilateral triangles. So these are all equilateral triangles. And so you have them alternate on the middle. And I believe there's 5 that make a pentagonal pyramid here. But instead of being rectangles, so it's like 2 triangular pyramids with the middle part being triangles instead of rectangles. But this top kind of area is like a triangular pyramid, and so is this bottom, or pentagonal pyramid, sorry.
How do you say that 20 equilateral triangle faces? How do you say it?
So this is okay, I'm pretty sure I could have sworn this is called an isohedron, but basically the last part is hedron. And I guess this is icosa. Maybe isohedron is different, so I apologize. But if you do want the official pronunciation, those are pretty easy to figure out. Google always has your back, you know. You can search up YouTube pronunciation as well, but they usually do a good job.
Do you know how to say the bottom 3?
Yeah, so this is a tetrahedron, so 4 triangles, octahedron, 8 triangles, and dodecahedron for 12. So we have our same prefixes. And this is
Excuse me?
More, yeah.
How do you say the last one?
This one?
Yes.
Dodecahedron.
Dodecahedron.
Yeah.
Dodecahedron.
So
Thanks.
sure. kind of a lesson on language, at least. Tetra or is like kind of the root for 4. Octa is for 8. And I think dodeca might be for 12, but I'm not too sure on that one. And so we see similar ideas with the other shapes as well. So like penta is for 5, hexa is for 6, hepta for 7, and then we have octa, and I think 9 is nonagon, and then not really sure the rest, but essentially these are all just names. So names, it's good to know, but not always too important. I think I will kind of wrap this up with what we've covered so far. So we went through 3D, introducing what a 3D shape is. We went through some of the basic 3D solids. And then we looked at Grog's notes just now, which was the colorful 2 pages of different shapes. So in the practice book, it says we have pages 18 to 23 as the guides, which we covered, which is just the solids chapter. So I'll start with this next time and kind of go through them. But if you want, you can work through some of the problems as well. But for assigned reading, I would like you to get through the nets chapter and the surface area chapter. And I will work on those kind of 3 problem sets.
What about the chapter nets?
Yeah. So the nets chapter, I would like you guys to read as homework, and same thing for the surface area chapter. So these 2, so from 26 to 38, or about 12 pages, I think.
How?
What's up, Juji?
How?
I don't have this book. I don't have it.
I think that
How?
so I don't know too much of what's of this, but I believe they are going to give you all pamphlets through the WeChat groups or something that your parents are in.
Please do.
Yeah, so double check with your parents, and I will try and make sure that on my end that they actually sent the pamphlets. But that's what I've heard. I'm not actually in the WeChat group. A friend of mine kind of introduced me to this. So I'm just here to kind of explain and teach. But I will ask them, and then hopefully I'll confirm that we have something by, say, Sunday. You guys should all get it at the latest. So if you guys don't have the book, don't worry too much. And then we'll be covering, like I said, kind of to review, I'll cover a brief overview of these 2 chapters. So I'll read them like you, and then give what I feel are like important notes from these 2 chapters. And then we'll go start through going through the practice problems. We might skip some of them depending on if we're short on time, or if it looks like the same stuff. So like we might only do 2 of these, for example, because they like maybe this one and this one, because they all seem pretty similar in for their problem. But yeah, did y'all? I kind of want to gauge the room real quick. Was this fast? Was this slow? Did y'all learn something? I guess. Do y'all want me to go faster, slower for next time?
I think you're good.
A little
I
hard.
feel way too fast. I don't know what you're even saying.
Okay, so speak slower or go through content slower.
Both.
Both? Okay.
Make
I
your
will
screen bigger.
make my screen bigger. Like, sorry, give me 1 second. Like this?
Yeah.
Okay.
Yeah.
Any other suggestions? So I think I'll do 200% then next time, if that's good with y'all. Does this look fine?
Yeah.
Okay. If there's no other questions, suggestions, I think this will be the end of our first session. I hope you guys learned something. Sorry for speaking too fast. Sorry for maybe going through content that was a bit fast. I was just surprised. I will double check. Maybe I'll have to apologize, but maybe there's an easier way to do it than what I did. So this question, I think, yeah, I didn't know that I had to teach, or I didn't know y'all didn't know about like kind of exponents and square roots. But hopefully at least these 4 questions made sense on how they worked with like perimeter and area. Yeah. It's okay to like not know what I did for this. I don't think you are going to be expected to understand that just yet. And yeah, with that, I think there's 2 minutes left, so 2 minutes early, you know. Have a good weekend, and yeah, just take care, stay safe.
Bye. Thank you.
Bye. Thank you.
Bye. Thank you.
Bye.
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 Bye. Thank you.
Bye.
Bye.
Bye. Thanks for coming.